Okay, I'm going to go over the review for exam 2. So if you're taking the online section, the geometry stuff was just on the quiz. So it is not going to be on the next exam. So if you just kind of want to check your answers here, you know, I'm not going to go over this. I can in a separate video if you're curious, but this is not going to be on your exam. So there's kind of the answers to page 1 of the review with the geometry. Again, if you want me to go over this with you, I certainly can, but it is not on the exam. So to save time, I'm going to just hold off on that. But those are the answers. And same thing on the top of the next page. This one, again, converting it into feet and then doing the price. One thing I would say with percents is when I do like tax, that's 6%. Instead of doing like this, multiplying by 0.06 and adding, I just multiply by 106% because that takes into account the price, which is 100%. Plus the extra 6%. It's just kind of a fast way of doing it. All right, we're going to focus on chapter 8 because that's what's on the exam. All right, so let's look at number 6. All right, so find the correct formula. All right, so remember, if you're dealing with anything with payments is on this chunk, this stuff is lump sums, meaning you invest one chunk of money or you borrow one chunk of money. It's not an ongoing thing, okay? All right, and then there's a few APR, APY is in there. But otherwise, this is if you borrow what we call a lump sum, meaning one chunk of money, or you save one chunk of money. And over here, we're dealing with payments. So that's huge, that much, okay? All right, so let's look. Simple interest. If it says simple interest, easy peasy, you're one of these two, okay? Now, if you want just the interest, you use this formula. If you want the what we call the future value, the money with interest included, you do this. The only tricky part about this formula is time is always in years. So if you're only like on a credit card, you do simple interest on a month-to-month basis. So on your credit card formula, they would do 1/12, not 1 because that would interest for 1 year. You just only want 1 month. So that would be 1/12, okay? So simple interest on a chunk of money would be I equals PRT. And again, that would just give you the interest. And again, if it's a month-to-month thing, you would only use 1/12 for time because 1 would be 1 year. All right. So if it is for a year, use a year. But if it's for 1 month, use 1/12, 2 months, 3 months, and so forth. All right. You want to compare 2% compounded weekly. Okay. Notice there is no money in this problem. And what are you doing? You are comparing interest rates, okay? The only formula we have that compares interest rates is this guy. This is your APR or APY, annual percentage rate, annual percentage yield, effective rate, yield. Notice there's no money in this formula. There's no P and there's no A, money with interest. This is just all you need to know is the rate and how it's compounding. That is this formula. So if you are comparing interest rates, you know it's that guy. That is a dead giveaway. Okay, so it's 1 plus r to the n raised to the n minus 1. There's no money involved. Okay, C, you want to find the money you would have if you invest $100 payments. So you're doing it all the time, compounded monthly. So you are trying to save with payments. Again, if you are saving money with a lump sum, you're kind of on this side. If you're saving money with payments, you're over here, okay? This is car or house, so that guy's out. This one, you're trying to figure out the payment, okay, that you need. This one is your payment and you're trying to save up. Again, A is future value, money with interest. So you're going to use that formula. Okay, so saving up using payments. So you have payment, double parentheses, what is that? 1 plus r to the n to the nt minus 1 n to parentheses all over rn. And again, if you're not good with your computer or you're, using a calculator, having an extra set of parentheses on that would not hurt, okay? All right, you want to find a car payment. That's easy. Payments, you're on this side. You have a choice. This is usually saving up for retirement, things like that. Either your payment, you want to know what you're going to have in 40 years. This is, I want $1 million in the future. What payment do I need? This is cars or house. Maybe a boat, something like that. But house or car payments are this guy right there. So if you want to find your car payment by hand, you have P, R divided by N, 1 minus 1 plus r divided by n, negative exponent nt there. And again, if you're not sure, it never hurts to put an extra parentheses around stuff to just make sure you get the top divided by the bottom. All right, you want to find the money you owe given, simple interest. There's only 2 formulas for simple interest with the principal. Okay, money you owe. Okay, simple interest, that's it right there. This one gives you just the interest. This gives you the future value, the money with interest. A always stands for money plus interest. And so you definitely need that formula right there. Now, the other option is to just figure out the interest and add it yourself. Okay, that's always an option as well. All right, you want to figure out what payment you need to save up $500,000 for retirement. Okay, you want to find, again, payments are on this side. This is, you know, your payment and you're saving up for something big. This is, you're trying to figure out a house or car payment. This is when you're trying to figure out a payment that you need to meet a goal, like to pay for a wedding in 5 years or to save for retirement in 40 years, things like that. Okay, so this is when you want to know what payment you need to save up to get to that future goal. Payments are on this side, so I know it's that formula. There's no debate. So A, again, R divided by N, all over double parentheses, 1 plus R to the N, NT minus 1. And again, every parenthesis matters. If you want to add an extra one on top, that would not hurt. Okay, right there. All right, this one, you want to know what lump sum, that's a chunk of money. You're not making payments. You want to know what lump sum you need to invest today to save up $30,000 for a car that you will purchase in 5 years. Okay, so you don't need $30,000 today. You need the $30,000 in 5 years. So that's the future value. You know what you need it to be worth in the future. And the good news about investing is you can save less today, so it grows to that, hopefully. All right, so again, it is a lump sum. You're over here. Does not say continuously compounding, okay? You're not comparing interest rates, it's not that, and it's not simple interest. So you have a 50-50 shot. Okay, this one, you know what you're borrowing or saving, and you want to figure out the future value, which again, A always stands for your money plus your interest, okay? Is that what I want? I'm not investing money here. I'm not investing $30,000. I'm investing less than $30,000, and I want it to grow to $30,000 in the future. That's the second formula. This is if I know my money goal in the future, money goal in the future. This is what we call present value. It's also the principal, but what is the value of that money today to get to that goal in the future? So again, I don't need to save $30,000 today. I need to save less, and then it's going to grow into the $30,000. So that's that formula. And again, you pretty much have a 50-50 shot on that one. What do I have? 1 plus R to the divided by N, what to the NT? Okay. All right, let's look at H. You want to find the amount of money you would have if it was compounded. Okay, if it says compounded continuously, there is only one formula on this whole sheet that does continuously compounding. It says continuously compounding. It is this guy, and it has the E in it. And again, on your E calculator, usually the E is above your natural log key. All right, so if I, like say I had $5,000 and I would go second shift, get the E, right? And then what does it take? My interest rate, so like 5%, again, move the decimal, times time, maybe again years, maybe it's 12 years, end of parentheses, all right, and then it would give me that value. And again, I usually take my exponents times each other separately just to save myself power. But again, if this is continuously compounding, there is no debate. It has to be this, has to be. There is no other choice. So P, E to the RT. And again, I usually take the RT off by myself and then just type that in. All right, you want to invest a lump sum. That is a chunk of money. So ignore the payment side. You're over here. Lump sum when compound interest, okay? So it doesn't say continuously compounding. We're not comparing interest rates. It doesn't say simple interest. We are there, okay? So again, the question is, do I know what I'm investing and I want to figure out the value in the future? Or do I know what I want in 20 years and I need to figure out what I'm saving today? Well, what does it say? You want to invest a lump sum. You want to know the money that you will have in the future. Okay, so you're going to invest a lump sum today, and you want to know how much money you're going to have in the future. That is this formula. Okay, you're going to invest a certain dollar amount. You want to know what it's going to grow to in the future. So that's P, 1 plus R divided by N to the NT. Okay, and again, when you use these formulas, be careful, like anytime, if I have, it's compounded, say weekly, and so weekly and maybe for 5 years, what I would do, there are 52 weeks in a year, n is 52 times 5. I would multiply that myself before putting it in as the exponent. Another error to watch out is if you have, 6 3/4% interest, which are mortgages and stuff, it's kind of common to have fractional. This is 6.75%. But again, to use the formula, you have to move the decimal 2 jumps, 1, 2. So in the formula, I would use 0.0675. And then I divide by, if it's weekly, I divide by 52. So just make sure you move your decimal on percents. And then for exponents, I tend to multiply them on scratch paper and then put them into my formula. All right, let's look at the next page. All right. And again, I don't know that did I put an amortization on there? If it's, I think I did. House or car, you use that one. All right, let's look at number 11. And again, they do jump. My computer did not update the numbering when I move things around. All right, you loan this much money to a friend. Okay, simple interest. How much money does she owe you after 7 months is up? Now, you have some options here. Simple interest is here. I usually just do the top formula and add, but you can do the bottom one and then you don't have to add. Okay, simple interest. All right, I equals PRT. Let's see here, $500. Again, move the decimal, 3%. Your decimal's here, 1, 2 jumps, 0.03. And time is in years, but see, this is 7 months. So I'm going to do 7/12 because if I put 7 in there, that is 7 years. Okay, so on my calculator, I'm just going to type this in. And again, with fractions, I always put them in parentheses, always. Okay, otherwise order of op is going to get screwed up. All right, $8.75. Now, that's just the interest. So if they're going to, pay you back, $508.75, and that would be what they owe you, because I'm going to take the original amount that they borrowed, interest, and that. Now, if you want to, you can use that other formula, and it's going to figure out the future value for you. So you just enter it. It's going to give you the amount with interest built in. So I could do that. That's this formula. And again, notice this one does not have any exponents, and that's because it is not exponential. It is simple interest, so it's linear. And that's 7, again, 12ths. Don't put 7 years in unless you mean 7 years. And again, I need to put that in parentheses and then the end of the parentheses. So if I type this one in my calculator, and again, practice typing these in with me and make sure you can use either decimals or, a simple calculator, whatever you have. And it helps if you type it in right. 7 divided by 12. And I can see if I have one, in another parenthesis, double parenthesis. I can see if I have a different one to show you too. So maybe in the next video, I'll switch out calculators. All right, so there we go. All right, you invest. Okay, what does that say? $200 per month. Now, the word payment isn't in there, but it is not a one-time deal. You're putting money in every single month. That is what we call a payment. If you make a car payment every month, it's a monthly deal. So just because the word payment isn't there, it's not a one-time deal. It is a payment. You're doing it every month. Okay, what are you doing? You are investing. Okay, you're not buying a house or car, so you're up here. I'm not asking you to find the payment. I'm telling you the payment. So the only formula, it could be this. This is when you're saving up for retirement or something, some goal, and you're using payments to do it, but you know the payment. It has to be that formula. All right, so $200 a month, 6% compounded monthly for 40 years. Okay, so I'm going to write this formula down. So we have a payment of what? $200. What do I have? Double parentheses. 1 plus my rate, again, move the decimal 2 jumps. So 6%, decimals at the end, 1 jump, 2 jumps. So it's 0.06. Compounded monthly, that means n is 12. Now again, n times t I do off to the side. So 12 times 40 is 480. Just saves my calculator screwing up. -1. And again, this is 480. How much time do I have? Not a lot. I'm going to leave that for now and then divide by that. All right. So we're going to type this in now again, and parenthesis there. I do the top and the bottom and then divide. If you really want to do it in one swoop, you could add an extra set of parentheses so that your calculator does the top divided by the bottom, but then you're kind of living dangerously then. But if you're great with the calculator, that should not be an issue. All right, I'm going to pick up here in the next video And maybe I'll grab my other calculator so you can see what that looks like too.